All right, here's the next set of notes. We're talking about springboard connections, connecting tables to graphs and expressions. Make sure you're on top of this, making it happen. All right, so it's some certain things. One, make sure you write this down, but there are certain things that you have to see. All right, so let's just take it back. Let's review for a second. So here was your table, right? You had your list of values right over here. So level 1, squares added, perimeter, total area. Now, this graph is directly connected to this table. So I see this is the connection of level number compared to number of squares added. So I can see that, well, in level number 1, it added 1 square. In level number 2, it added 3 squares. 2, 3 squares. Level number 3, 5 squares, and so forth. I can see 3, 5. Okay? You all made this graph already. So one of the questions I was asking you all in class that people were struggling with to understand is basically, okay, what is the expression that goes and connects level and squares added? Okay, what is the expression that tells me how I go from levels to squares added? So if I look at this, how did I go from a 1 to a 1? How did I go from a 2 to a 3? How did I go from a 3 to a 5? And the way that we did that, again, is saying, well, I either take the level plus the level minus 1. Remember, if I take 2 plus the level before it, 2 plus 1 gives me 3. 3 plus the level 3 minus 1, so 3 plus 2 gives me 5. 4 plus 3 gives me 7. That was one of those connections. Or some of you found the second connection, which says you take 2 times the level minus 1. So 2 times 2 is 4, minus 1 is 3. 3 times 2 is 6, minus 1 is 5. So do you see how this equation matches with this, this expression goes along with this graph? Okay? So now we're saying, how does the next expression go with the graph? So again, first of all, from the chart I go, how did I go from level number to perimeter? Level 2, the perimeter is 8. Level 2, the perimeter is 8. Level 5, the perimeter is 20. Level 5, the perimeter is 20, and so forth. Well, what is the pattern between level and perimeter? Level and perimeter. Level and perimeter. 4 times 4. 5 times 4. 7 times 4. So that expression is the level times 4, or 4L. From table to graph to expression. All three talking about the same thing. Finally, over here talking about how do I move from level number to total area. Level number to total area. Level number to total area. 5 times 5 is 25. 3 times 3 is 9. 4 times 4 is 16. 8 times 8 is 64. You take the level number and you multiply it by itself. L times L, or L squared. So you have a chart to a graph, right? Level number 9, total area is 81. Level number 9, total area is 81. Level number 7, total area is 49. Level number 7, total area is 49. Go from a chart to a graph to an expression that shows it. Okay? So that's one of the connections that you have to make. So what you need to do on your paper, I'm not going to do this, is 1. So when you come back, I'm going to see you answer this question in a paragraph. Explain how the table, the graph, and the expression are related to each other. You're going to explain that in your own words, and that's one of the things you have to do. I'm not doing it. So that's what you will write down in your notebook. Now, You should pause it right here and make sure that you give that explanation. If you need to go back and look at the video, do that. I don't care. Whatever you have to do, make it happen. You will get no credit if I don't see something on this that makes some kind of sense. Okay? So you're going to do that work here. Second thing you need to think about. Okay? Let's look back at these graphs. Okay? Actually, let's put this here. So the second thing you're going to talk about is constant graphs versus inconsistent or changing graphs. Okay? So, I'm going to explain this and you're going to write it in words. This graph and this graph are both constant. The reason why they're constant, they make a straight line. I always go up the same amount and over the same amount each time. They have the same slope. This one, this is perimeter went up by 4, plus 4, plus 4, plus 4, plus 4, plus 4. It moves up by 4 each time. Squares added, if I remember correctly, goes up by 2, plus 2, plus 2, plus 2, plus 2, plus 2. It's constant. It makes the straight line if I graph it out there. Now, let's compare that to this third graph. This third graph is curved because guess what? It's not constant. Look at total area. Remember, this is talking about level compared to total area. Total area right here goes up plus 3, then it goes up plus 5, then it goes up plus 7, then it goes up plus 9, then it goes up plus 11, excuse me. Notice, it's always changing. It's not the same every time. It's not consistent. It's not constant. It's inconsistent. So, when I don't have a constant, I don't get this straight line anymore. Now, I get this curved line. Right? Now I have this curved line. And notice, when I have a curved line, I get an exponent. This doesn't have an exponent. This doesn't have an exponent. This up here doesn't have an exponent. But because they're constant in their lines don't have exponents. But when I get this curved line, I start talking about exponents. So, in constant graphs versus inconsistent graphs, tell me, what is the difference? And I've already told you this, between a constant and an inconsistent graph. That's one question. The second question you need to answer. You have to go back and look, and you need to answer this. How can I tell if an expression will graph a constant, which is a line, or not? That should say, how can I tell if I'm going to get an expression that graphs a constant or not? What would I look at in that expression? You're going to answer 2 of those in sentences, and that's what you're going to come back with. The last thing we're talking about. Okay, so you're going to do that on your paper. You probably want to pause it right now and make that happen. Last thing that we are talking about says finding patterns in tables. If you did last night's homework or the homework over the weekend, we talked about patterns in tables. I'm going to give you a table and you have to tell me what the pattern is. Hold on. Here's your new table. It says, Boom, 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 boom. There's 1, 2. Figure out what is the pattern. 6, 7, 8, 9, 8, 10, 12, 14. What is the pattern that relates 1 to 2? Right? An expression that works for this table. That's what I'm looking for you. Write an expression that works for this table. You do all of that, you will be good to go. Some of the stuff you just got to think about. This one you got to figure out on your own. But it's very, very similar to the one that you had in your notes from the previous night. So if you don't know what to do, look back at that video. Bass, out. Have a good day.